of cubes. And why I like the new version of this lesson is it goes right back to the beginning and says, what do you mean factoring a sum or difference of cubes? Does that title seem familiar at all to you? And it should. Do you remember difference of squares? Does that ring a bell? And even if all you remember is the name, you're like, I don't remember what it does. I don't remember how it works, but I do remember hearing the words difference of squares before. I'm going to re-explain it all, but in a slightly different way. The whole time I'm teaching this part, I'll be thinking about sum and difference of cubes. I'll be saying the things we need for sum or difference of squares. So even if, or for sum or difference of cubes. So even as you're walking through this, you're like, I remember this totally. If it's total review, try and pay attention to the words I use and how I phrase things so that the second part of the lesson is easier for you, okay? Let's review difference of squares just in case. When factoring trinomials, a special case appears. Wait a minute, let's review factoring trinomials for just a second. Let's make sure we're right caught up of where you were in grade 10 or grade 11 when difference of squares appeared. You'd be going along doing trinomial factoring, maybe x squared plus 7x plus 10. And back when these questions came up, people still liked factoring because it was a fairly regimented procedure. Find two numbers that multiply to 10 but add to 7. And even if you weren't good at your multiplication tables, it didn't take too long to figure it out. Go, okay, so what multiplies to 10? 1 and 10 multiplies to 10, but that doesn't add to 7. 2 and 5 multiplies to 10 and adds to 7, and then so factoring just became x plus 2, x plus 5. Let's be clear on why that works, is because if you FOIL this out, you get x times x is x squared, and then you get 5x and 2x. Those two have to add together to give the middle term, and then they have to multiply together. 5 times 2 is 10 to get the last term. So basically you're unfoiling. Okay? So that's where difference of squares fits into the procedure, is you're doing trinomial factoring, easy trinomial factoring, because there's no coefficient out front here. And a special case appears. X squared minus 25. Now it's a binomial, which freaks you out at first until you use your brain a little bit and go, well, this isn't technically a trinomial. However, it could be thought of as a trinomial by making the missing x term have a 0 coefficient. That's not how we teach it in grade 10 usually, because I think that would scare people off a little bit. But for you especially, I think now it's like, okay, I get that now. X squared plus 0x minus 25. How do we factor it now? I'm looking for two numbers that multiply to negative 25 but add to 0, and there's an extra clue here. This is actually a little bit easier because you know what the two numbers have to be if they're going to add to 0. Negative 5 and positive 5. There's a different way to think these out. You don't have to think that way, but what you get is x plus 5, x minus 5, because 5 and negative 5 add to that 0 that I'm looking for that wasn't there to make it a trinomial. But maybe there's a faster way. When you see a difference of squares, maybe there's a faster way to do this. Yeah, square root's right there just to go, can't we just square root these? Okay, to be able to do square root of each of them, we have to have a couple of clues that this is what's going on. First of all, the first clue is it's a binomial, not a trinomial. The second is both of these things have to be something squared. There has to be some square root of each of these, and there was. Square root of 25 was 5. Square root of x squared was x, and that gave us the hint we needed to not have to go through all that other thinking, all that add to, multiply to. And it's not just about being a shortcut. It's nice that it's a shortcut, but it's not just about that. There's a little more to it than that. Notice that the terms in each bracket can be predicted from the original question, how? Each term is a square root. I'll try and write it like that because that's exactly what she said there. Couldn't square root help us out here? And then there's a box there that probably didn't get explained exactly like this in grade 10 or 11, but it's a good box for us in grade 12. Factoring a difference of squares. Given a binomial. So for this to work, we have to start with a binomial, two terms, with each term being a perfect square. So there's two things that have to happen. First, it has to be a binomial, and then each term has to be a perfect square. If that happens, you can follow this pattern. A squared minus b squared is a plus b, a minus b. That's what I did on the previous page. This x I'm calling big A, And this 5 I'm calling big B. And so when I went to do the brackets, I went A plus B and A minus B. Don't get distracted by the A and B. The A and B is just trying to tell you whatever's here and whatever's there. You know, when you see A minus B, you're just like, whatever was there and whatever was there. They're just telling you what things to look for here. Where A and B are the square roots of those perfect squares. They got to be squares for this to work. Does this all ring a bell? Even if you didn't remember right away, hopefully I'm scraping the rust off and you're like, oh yeah, I'm starting to remember how this all works. Remember, it's not just a shortcut. It allows us to handle crazy ones. Here's a crazy one coming up. This thinking helps us handle those crazy ones. Question? I like that you said common factor because that's going to come up later in the lesson, and I'm going to pretend like she didn't say that when we get there and act like common factoring is this big scary thing when it's really not. This particular one, yeah, I think, yes, I think we're just using the wrong words, that's all. So let me just go after this one with some different words, and then hopefully you can use the right words here and explain what you're thinking. Here's a new way to think about it, and I say that in that grade 10, 11, you might not have thought of it this way. The way I want you to think about it, to get ready for sum and difference of cubes, is you go, okay, I get given something to factor, and it's a binomial, 2 terms. And in this case, it's got to be a difference in between, and all of these are, they're subtracting between. Your job, figure out if these are perfect squares. Are these something squared? That is there something squared that gives 64? Hopefully your multiplication tables are good enough for this one, where you go, oh yeah, that's 8 times 8. But if they weren't, it's okay. You could go to your calculator and you could go square root 64 and check and find out, yes, it's 8. So you could do that if the numbers get too big. So yes, this was something squared. That something squared was 8. I like writing them in beside there. It really helps my thinking to write them beside them. Now this one is so easy it's hard. Is there something that you can square to get x squared? Yeah, x, that's actually pretty simple. So I'm going to write way over here to make myself some room here. And so the pattern says, if you've got something squared, and here my big A, if you want, is x, and here my big B is 8. My difference of squares pattern, which you might think is overkill to memorize this, but I'm using it for the second part of the lesson. So stick with me on this thinking, even if you don't need it for difference of squares. Once I found the A and B, the first bracket is A plus B. The second bracket is A minus B. So I've got, in the first bracket is x plus 8. And the second bracket is x minus 8. And actually, it doesn't matter if you write the brackets in the other order. But I always write it with the positive first. I don't know why. There's no good reason for that. Is that pretty good? Okay, so now I'm just going to reuse that 2 more times, that exact same thinking, to finish off our review of difference of squares. But I'm up to something here. Let me tell you, there's a plan here about how I'm doing this so that sum and difference of cubes we might find easy. Okay, here's the thinking. When I have to factor something, and it's a binomial, my brain triggers and goes, maybe this is a difference of squares. It's got to subtract in between, so it's got a good chance of being difference of squares. We're going to talk about why it has to be subtract in just a second. I'm going to show you how to check these answers. So your job is to figure out, was something squared? Are these perfect squares? Is there something you can square to give 121? And maybe your multiplication tables aren't good enough for that. Maybe they are. So you get your calculator and you go, well, let's just check. Square root 121. I'm hoping for something that doesn't come out to a decimal. And I get 11. There is something squared that gives 121. It's an 11. The B is 11. That was what was squared, the second term. Now 9y squared. We've got to use our brain power here a little bit. What do you square to get 9y squared? 3y. I almost said she almost missed the y, but she didn't almost miss. We almost missed it in period 2, I got to tell you. We had the 3, but it's also y. It's something that has to multiply by itself to give 9y squared. So 3y times 3y is 9y squared. So that's the A if we're going to use the pattern from the formula. So our first bracket is A plus B, these two things added together. And the second bracket is A minus B, those two things subtracted. Maybe with that one you start to have some respect for this pattern, because it really helps with the thinking. And maybe you're like, no, you just got to add and subtract. But let's talk about why it's add and subtract, and why with squares it has to be a difference, okay? This is AP type thinking here. This is like really delving into what's going on here. Let's say you weren't sure. You're like, I don't know if it's right. I just want to check this to make sure. So you decided to FOIL it out to see if it works. 3y times 3y is 9y squared. And now you're feeling pretty good about the situation because 3y times 3y is 9y squared, and that's what I needed for the first term. And that's why this first term is just the square root of that the first term in each bracket is the square root of this thing because they got to multiply back out to give 9y squared. Then you start losing faith. 3y times negative 11 is negative 33y, and there's no y's in the original question, making you believe that maybe you've made a mistake here. Then you do the next term. 11 times 3y plus 33y. And then maybe some real deep understanding of difference of squares comes. It has to be the same terms in both brackets, and it has to be add and subtract so that we get add and subtract and cancel out those middle terms. Those middle terms have to cancel. Then the last term, plus 11 times negative 11, negative 121. And then maybe you even get a step farther, understanding difference of squares, where you go, oh, it's got to come out to minus. If the brackets are going to be add and subtract when I multiply, that's got to be a negative there. It will only work difference of squares. It has to be a subtract. An add won't make this happen. Okay, now we're all the way back to this really tough one. And our job is find out if it is a difference of squares. Yeah. It's a difference. It's got to subtract in between. But the question is, are these perfect squares? Was something squared to give each of these terms? And it's a little bit tough now. Got to do some real thinking. 9y to the fourth. What do you square to give 9y to the fourth? 3y to the power 2. You've got to use your brain. There is a shortcut, but I'm scared of it just a little bit. I'll tell you about it in just a second, but I'm scared of it. I think it's better just to write something down and go, is it right? 3y squared times itself would be 3 times 3 is 9. Y squared times y squared is y to the fourth. I think that's the right way to do it in grade 12. It's just think it through. Let's do another one, and then we'll see. We'll just mention the shortcut. I don't want to live on the shortcut, but 100x to the power of 8. What do you multiply by itself to give 100x to the power of 8? 10 is the coefficient. How about the x to the fourth? And hopefully you're doing what I said, which is going x4 times x4 is x to the 8. But there is a shortcut if you wanted to do 4 plus 4. Because we're exponents, right? Those ones we have to add. This is why I'm scared of the shortcut. Yeah? Because the shortcut can cause problems. And the shortcut is just to divide the exponent by 2. But I'm really tiptoeing on that. I don't really love that. I love the check, where you just look at it and go, is it right? 10 times 10 is 100. Yeah, x to the fourth times x to the fourth. Add the exponents, x to the power of 8. I think that's the way to handle that. Did I say 4 times 4? Yeah. Maybe that's why. It'd be 4 plus 4. Yeah, good. Okay, now you have a little more respect for the pattern now. If this is the A, and this is the B, then my first bracket is those two things added together, and my second bracket is those two things subtracted. A plus B and A minus B, but it actually doesn't matter which order these brackets go. You can multiply them the other way, and you still get the same thing. Any questions about difference of squares? The keys are you're looking for two terms, and you're looking for perfect squares in both of them. This is all pretty good. We have to be really good at this point in the lesson. Okay. That's grade 10, 11 stuff. That's really not what we're doing in this course. What we're doing is extending out to cubes. Is there a way to do a sum or difference of cubes? And the answer is, of course. That's what the lesson's called. It's going to be there. So that's it for review. The big question in this lesson is, this is where the lesson really starts. Can this be, not red, whoa, yellow highlighting. Can this lesson be extended to cubes? And obviously it can, or I wouldn't have it here. But it's going to take a little examination for it to happen. And to do that, I'm actually going to review the factor theorem. So if you're a little behind in homework, or you weren't real clear exactly how the assignment was supposed to finish off, I'm going to review everything you need to know about factoring right here. I'm actually going to factor these the old way, hopefully to find a new way. When you get given something, x cubed minus 125, this is what you're supposed to know about factoring at this point, is you'd go let p at x equal x cubed minus 125. You first give it a name. And then if somebody asked you about factoring right now, you might tell them the plan is just to sub in random numbers until you get 0. And that's a pretty good description of what's going on, but it's not perfect. The perfect description is I'm going to sub in certain numbers. Yeah, she's seeing right through it that the third root of 125 is definitely going to work here. But if I didn't know what was going to work, I wouldn't just sub in random numbers. The numbers you sub in have to divide into 125. That is, I don't have to worry about 2, 3, 4. None of those divide into 125. So take that random number out of the description when you're talking about factoring and say certain numbers. I'm going to sub in certain numbers. I'm going to use my brain about what numbers to use. So I do try 1. I go p at 1, and I get negative 124. And I try p at negative 1, and I get negative 126. So those didn't work. The ones didn't work there. You can punch those in your calculator to see if I did them right. So then you don't try 2. Don't try 3. Don't waste your time on those. They can't possibly work. Then I try p at 5. And I get 125 minus 125 equals 0. And I'm very, very happy to see that 0. Because it tells me a lot of information. And here comes the review of the assignment right here. I'm giving away everything that's on your assignment. Because p at 5 was 0, I then know, therefore, x minus 5 is a factor. I found a factor of this thing. And yes, the 5 was the cube root of 125, which is on the way to leading to our shortcut to do this. I'm doing all this so that maybe we can do this with a shortcut. Now, once we have that x minus 5 as a factor, we want to divide it off. So I go k equals positive 5. Now I'm reviewing division here. I'm reviewing synthetic division. If you want to divide by x minus 5, you want a k value of 5. And so, let's see, x cubed minus 125. 1x cubed long, scary pause here. What's the next coefficient? 0x squared. Say it out loud as you're doing them. Say every power out loud. 1x cubed, 0x squared, 0x minus 125. So watch out for those missing terms. They have to be put in at zeros for this to work. Well, hopefully you've done enough practice that if you get to this stage, you're pretty good. You bring down the 1, multiply by 5 and add, multiply by 5 and add, multiply by 5 and add, and you're happy about the 0 again, but maybe not as happy as you were before. When you found this 0, you were extremely happy. You're like, oh, found a factor. Whew. When you got this 0, you're like, yeah, of course it has to be 0. That's what the assignment was saying. If you sub it in and get 0, when you divide, you'll get remainder 0. Those two zeros match up. And that because it's 0, it must be a factor. Well, I'm done. Therefore, x cubed minus 125. The first factor was x minus 5, right there. And the second factor is x squared plus 5x plus 25. And apparently, Mr. Todd seems to imply that there's a pattern here to the numbers that potentially could be used to jump from here all the way down to here, to skip all those steps in this case, because this is a difference of cubes. What was cubed to give x cubed? X. And this was a 5. 5 times 5 times 5 is 125. I'm doing cubes this time. And take a look at these brackets. I chose this one on purpose because it's a little easier to see the 5s in the pattern here. X and 5 were was the A and B this time. First bracket, x minus 5. We're off to a great start. You know, that's not hard to remember that whatever your two perfect cubes are, or the cube roots there, that goes in the brackets. Then this one's a little more complicated. X squared, maybe it's this one, the first one squared, plus 5x, maybe that's the two of them multiplied together, and then 25, maybe it's the last one squared. That's really what it is, but I'm really trying to lead you to it, that you can really see the pattern here. I'm going to do one more and try and see the pattern again. And review factoring again. But is there any questions on those steps? That's really our review of the whole chapter. The whole chapter is right there. Division, assignment, and factoring all in one example. Yeah? Question? Yeah, you should finish this off. And I should have mentioned that just now. This particular one doesn't keep going. A lot of the ones we choose for the test and in the homework do keep going, and you can factor this last step here. But there isn't two things that multiply to 25 and add to 5, so this one you can't keep going. If you're thinking, what about the quadratic formula? Well, that's what I'm going to talk about in the first lesson of chapter 4, is like, what happens if this last quadratic doesn't factor? For us, if it's just asked to factor, that's as much factoring as I can do in this particular one. But yeah, you're right. You got to check for that next step usually. Okay, well, hey, I'm going to do more essentially review here. I'm going to do another one here because I want to establish this pattern. This time I'm going after x cubed plus 27. I've chosen the numbers carefully here that maybe we can really see the pattern before I pronounce the pattern here. So I sub in p at 1, I get 28. P at negative 1, I get 26. Does anyone in their own words want to tell me why 2? I can just skip 2. Why 2 is not going to work out? Yeah, there's no way to take 2, multiply it by itself a bunch of times, or do anything with it, and end up with 27. So there's no way it can end up getting rid of that 27. That's why the shortcut. It has to divide into the 27. So if I try 3, I think I get 54 here, but when I do try negative 3, I get 0. That one works out. Come test time, I think the biggest I've ever used is a 4, I think. To find that first factor. That's the stressful moment of the test when you're subbing these in going, please let one of these work, and so I won't leave you out to dry. I think the homework doesn't, I think the biggest I've ever seen is a 5. The biggest number you got to try is a 5, so. Anyways, big moment from the assignment. Therefore, x plus, I'm copying from the other side, not reading what I have. Therefore, x plus 3 is a factor. That's what the assignment was saying, is if you sub in something and get 0, you found a factor, because there won't be a remainder there. So now I'm using k equals negative 3, 1, 0, 0, 27. Let's just pause for a second. Remember what I'm trying to accomplish here. I'm trying to review factoring, yes. But this lesson specifically is trying to find a way to skip all these steps when it's a sum of cubes like this one is. Just put that up there. And so bring down the first one, multiply by negative 3, add, multiply by negative 3, add, multiply by negative 3, and add. Hopefully that's well practiced. If it's not, oh boy, it is getting late in the game to not be able to divide. Like we're getting, it's almost panic time. If that is mysterious. Not that you couldn't ask me questions. That might be a good strategy, to panic right now and ask questions. But we need to be able to divide at that point. So we're done, I think. X cubed plus 27 equals, I found one factor, x plus 3, and the other factor is x squared minus 3x plus 9. And I will mention that this piece does not factor. There isn't two numbers that multiply to 9 and add to negative 3. So I've gone as far as I can with factoring. But this lesson isn't trying to do that. I used it to review that. But what we really want to know is there a way to jump all the way from there to there? Take a look. If I went back to x cubed plus 27 and looked at this as a sum of cubes and found the cube root of each of these pieces, I would have got x and 3. And do the x and 3 appear here? Yes, the first bracket is just x plus 3. So that's a good start to a great pattern because it's just the two things added together. Notice with the difference, it was subtract in the first bracket. With the sum, it was add in the first bracket. The second bracket's a little more mysterious. x squared, which this could be this squared, minus maybe the two of them multiplied together, plus this one squared. And that is exactly the pattern that happens out of sum and difference of cubes every time. Your first bracket is either a plus b or a minus b, depending on whether it's a sum or difference. And the second bracket is the first one squared, the two of them multiplied together, and the second one squared. That will happen every time with sum or difference of cubes. I'm not done teaching this, but do you sort of get where I'm going here? Is there's a pattern each time that plays out. It's a little more complicated than difference of squares. The first bracket has two terms, but the second one has three. If it's mysterious, we'll multiply it out. Let me do it. This is a really big time move. Let's say on the test you'd write this all and you go, oh, I don't feel great about it. I don't know if I remembered the pattern right, and you're freaking out. Just take a second to multiply it out, see if it works. X times x is x cubed. X times negative 3x is negative 3x squared. And x times 9 is 9x, and you're freaking out at this point. You're like, it doesn't work. Look it. It's not x cubed plus 27. Then you finish multiplying it out. 3 times x squared is 3x squared. Huh? 3 times negative 3x is negative 9x. And then I get plus 27. Cancel, 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 cancel. X cubed plus 27. The pluses and the minuses are in all the right spots to be able to jump from here all the way down to the bottom.
Is the k value always going to be in that second term? Like the negative 3x squared minus 3x plus 9. Like that's with negative 3x.
I'll say yes. Yes, it is. Because it really is, this k value actually is the b. So those two things are the same. So I won't call it the k value. I'll call it the b value. But you're right, it is the same number.
Okay.
Yeah. You're going to like the next slide. I guarantee it. Well, you tell me. I think this may sound, it's meant to be a compliment. I think you're a memorizer. And so if you are a memorizer, which is a great skill, by the way, it's not, it sounds like maybe I'm putting that down. No, memorizers are in great shape here because there's a pattern that we can think here. And I'm just trying to motivate the pattern. Go, look it. Isn't there something going on here? X and 3, x squared minus 3x plus 9. There's something about those numbers. Look at, when it was 5, that last number was 25. When it was 3, that last number was 9. There's something about this pattern that happens both times. And I use 3 and 5 on purpose because 3 and 5 are easy to sort of see them play out. Here's the pattern. Do you see a potential pattern? Yes, I do. Does it work now also work for addition? Yes. The pattern came out of addition as well as subtraction. In difference of squares, it only could be subtraction, but it works for addition here. Here's the fancy pattern. Factoring a difference or sum of cubes. Given a binomial, with each term being a perfect cube this time, we can use these patterns. A cubed minus b cubed. First bracket, a minus b. Once you find those cubes, you're just a minus b. Then a squared plus the two of them multiplied together plus b squared. This is mysterious. Don't worry. I'm about to do this 6 times. I think there's 6 more examples where I go how to use it, you know. If it's sum of cubes, look at minor differences here. Sum of cubes means the first bracket is plus, but the second bracket now has a minus. And maybe seeing me multiply it out gives you a flavor of why there has to be a plus and minus somewhere so that things cancel out and you don't get a million terms here. Where a and b are the cube roots of those perfect cubes. Now we'll be cube rooting. So we might need our calculator this time. Maybe square roots, you're like, oh, I can do square roots in my head. But cube roots, you might need your calculator to think them out when you're first learning them. Let's try and use it a couple of times. Before you let freak out happen, let's see it in motion with a pretty easy one to start with. X cubed minus 64. And I'm going to go back and forth with the pattern here. Notice how similar the speech is for difference of cubes from difference of squares. You're looking for 2 terms. If you get a binomial here, it's potentially a difference of cubes. And so you look and say, is there something that cubes to give x cubed? It's almost too easy when I say it like that. Yes, x gets cubed to give x cubed. And what gets cubed to give 64? Well, you might not have the cubes in your head. You might not, but you have your calculator available. What cubes to give 64? 4. But if you didn't know that, you open your calculator. My calculator has a cube root button, has a little 3 root, and I put that cube root 64 equals 4. So you might need your calculator to find the cube root of that thing. So that's the A and the B for my pattern. All right, I don't know who to talk to, the non-memorizers or the memorizers. The non-memorizers might be home already. They're like, I get the pattern, I'm home free already. So I'll do that with the non-memorizers first. Non-memorizers are going to go, well, I've got my A and B, and this will subtract, so the first bracket is x minus 4. Second bracket, I square the A, I multiply them together, and I square the B. Memorizers. This is from the formula. This is A minus B. And this is A squared, AB, and B squared. You're just going to memorize that formula. Notice the minus and plus. I don't think the minus and plus is a big problem for memorizing. If it's minus here, the first bracket gets the minus, and the second bracket has to be plus. We need the minuses and pluses to cancel out. So even if you are a memorizer, you might be like, oh, wait a minute. There's a lot going on here that I can just easily memorize. It's not going to be a big memorization problem. I'm running out of space here, so I'm going to just draw a line here. I'm doing 6 of these, by the way. So remember this. When you're learning something new like this, if there's 6 examples, after the first one, you're like, I kind of get it. You're in good shape because each example is going to help you out a little more. Question?
So when you do A times B, you're not going to use it as a negative 4, you're going to treat it as a normal 4.
Yeah, I just picked out the, see, this was difference of cubes, so I just picked out the 4, not the negative part of it.
Okay, that makes a lot more sense.
Yeah. And the minus is here
Yeah.
and not here.
Yes.
Yeah,
Because
good.
when you do x times 4, it's not going to be -4.
Good. Great stuff. Let's try another one. I moved it down to here because I don't want it to be jammed right in here. X cubed plus 8. Here's the whole thinking, start to finish. When I see 2 terms, I start thinking this could be a sum or difference of cubes. I know it's not a sum or difference of squares because these aren't squared things. You know, they're not 8 isn't something squared. So then I go, well, what was cubed to give x cubed? X was cubed to give, so my A is the x. And then my B is what was cubed to give 8. Maybe you can do that in your head. But you don't have to rely on that. You can just use your calculator. Yeah? 2. So, non-memorizers are going to just get it. They're going to go, okay, first bracket is x plus 2, because this was plus, so it's just those 2 added together. Second bracket, square the first thing, multiply them together with a minus, and square the last thing. That's not what memorizers will do. They'll know it's, the brackets are a plus b, a squared minus ab plus b squared, and they'll just plug those right in there using their formula that they've memorized. Best way to handle this actually is have the formula memorized, be sitting in your desk 5 minutes before the test going, hey, a cubed, and then teacher puts the test down, you're like, boom, you just flip it over, you write down the formulas, and now they're not bouncing around your head anymore. You just write them down right at the start of the test. I pause for questions because that's the gist of it. The rest is just details and examples that might be a little more scary than this. Do you have questions about the procedure there? If it's bad at all, if it's difficult for you at all, then memorize. Be a memorizer then. Memorize these 2 formulas. Okay. Slowly. This one. When I see 2 terms like that, a binomial, I'm starting to think maybe difference of squares, maybe sum or difference of cubes. And at first, this could be a difference of squares, except 216, when I square root 216, it's not a perfect square. I get like some weird decimal. So then I go, maybe it's a difference of cubes. So I go, what was cubed to give x cubed, or x to the power 6? I'll let you think about that one for a second while I go work on B, because that takes a little bit of thought. 216, how about, is there a cube root of 216? Cube root 216 in my calculator. You definitely should try that out in your calculator before too long to make sure you know where the cube root button is. And I get 6, so I'm pretty excited that this could be a cube root. But what's the cube root of x to the power 6? X squared. I don't necessarily suggest memorizing the pattern here. You could, or memorizing the trick here. You could memorize, just divide the exponent by 3. I think it's better to go x squared times x squared times x squared. Oh, that's x to the power of 6, because I add all the exponents up. So what I get out of the pattern is, first bracket, subtract the a and b. A lot like difference of squares. Second bracket, square the first one, multiply them together, and square the last one. If that's all mysterious, it's straight from the formula. The formula, the formula said, first bracket, a minus b, second bracket, a squared plus ab plus b squared. Not a lot to memorize this chapter, so maybe memorizing one thing is worth it here, unless you already get it. I know there's some people out there that are like, I already got it. Squared, multiply together, squared. I'm good. See you tomorrow. Okay. Questions about number 3? What we got? 3 left? 4, 5, and 6? I think my memory tells me bigger terms, scary step, and then I won't even talk about the last one. I'm just going after crazy ones now. If there was no crazy ones to deal with, that would be it. That's sum or difference of cubes right there, but there's some crazy situations to deal with. More time here? You need more time on this one? Okay, here come the crazy situations. When you see 2 terms, you're thinking maybe sum or difference of cubes. You go, is there something I can cube to give 27x cubed? Let's see. 3x? And is there something I can cube to give 125 y to the 6th? 5y squared. Good for you. It's easy to mess up the exponent one, like the variable power. So you really got to think it through and make sure you got it taken care of. So that's the a and the b for your pattern. You go back to your pattern, you say, okay, first set of brackets is just add these 2 things together. Second set of brackets, square the first one, multiply the 2 together, and square the last one. Let me double check that I've done that right. Yeah. What did I just do in my head? Does anybody know what I just did in my head? I multiplied it all out. If you weren't sure, you could multiply the whole thing out. It doesn't take that long, and then you'd feel great about it because all the positives and negatives work out for you. Okay, 7x to the 4th minus 448x. With 2 terms, we think maybe it's a sum or difference of cubes. So what do you get cubed to get 7? Why is this in here? The way I've taught this lesson might have led you astray. It might have made you believe the first thing you should do when you're factoring is check if it's 2 terms or not. And that's not true. That is not the first step of factoring. The first step of factoring, whenever you see it, as soon as it says factoring, you're thinking something different. So I've got to fix that before this lesson ends. The first step of factoring, the first thing I'm always looking for, look at I'm hitting myself in the head here. What do I look for first? Not if it's 2 terms or not. What's the very first thing? I'm praying because I just know it's going to cause you problems. On the test, if you've done the practice test, on purpose, I put one in there, like a landmine in the middle of the test to go, common factor this thing. Actually, I take back. Don't write these 2 formulas on the test as soon as I hand it to you. Write down what we're about to know here. This is what you have to know and watch for on the test or it's going to trip you up. What's the very first step of factoring? Always. It's going to come back to haunt you. It's going to come back to haunt you in polynomials, calculus, trigonometry, all the way through. Common factoring is always the move first. So when you get your test on Friday, and I set it down right across the top, common factor first. Yeah? That is the most important thing to remember for this test. So you check to see if there's a common factor. I see a 7 there. Does 7 divide into 448? I don't know. Get my calculator, right? 448 divide 64. 64 is exciting for two reasons. It's a whole number, but it's 64. 64 is good for what we're doing today. So common factor out the 7, but also an x goes. There's a common factor of x in both of them. So I'm left with x cubed. What was it again? 64. It's order pizza time. Yeah? As soon as you pop that common factor out of there, now I've got two terms, and they're both cubes. This is x cubed, and this is 4 cubed, and now I can do my difference of cubes. X minus 4, x squared plus 4x plus 16. Done. A minus b, a squared plus ab plus b squared. Just follow the pattern. This is a, and this is b. One more to go that doesn't look like much trouble. X to the power 9 minus 512. Two terms, so I'm looking for the cube root of each term. Cube root of 512, can't do it in my head, so I go cube root 512. 8, oh, that's good news. And then x to the power 9. This time I divide the power by 3. That's the shortcut for these, if you want a shortcut. But I think it's better just to think it out and go x cubed times x cubed times x cubed. 3 and 3 and 3 is 9. So I get my 2. I'm going to move down here because I know something maybe you don't realize at this point. First bracket, x cubed minus 8. Second bracket, x to the power 6. That's the a squared. Plus ab, which is 8x cubed, plus b squared, which is 64. Let me just check that. It's right. Factoring is a pain sometimes. Every once in a while, factoring comes up to haunt you. I wrote equals there. It might be asking a lot to see what has to happen next, because you're really new in the last half an hour to sum and difference of cubes. There's another difference of cubes there. Every once in a while, a second one pops out of there. And so then I need, my a is x and my b is 2. So this is x minus 2, x squared plus 2x plus 4. And then that whole messy bracket over here. So watch out for that. Every once in a while that pops up. That's not really a test hint. I don't know if I've ever been cruel enough to put a double difference of cubes on a test. You're like, well, why aren't they in the homework then? The idea is if you can do a double one in the homework, then when the single ones appear, you can handle those no problem. I mean, there's a reason why we put really tough questions in the homework sometimes, is to get you ready so that you think the test questions are easy. Yeah, that would be the good thing. Let's make sure I didn't make a mistake here. Do you know what I'm doing right now? Here, watch what I'm doing right now. X times x is x cubed. I'm feeling pretty good. X times 2x is 2x squared. I'm a little scared now because that didn't have 2x squared in there. X times 4 is 4x. Negative 2 times x squared is negative 2x squared. Oh, it's good. Negative 2 times 2, negative 4x. Oh, it's perfect. Negative 2 times 4 is negative 8. You see, how long did that take to multiply that out? It looks like a big job. Oh, I got to multiply out the brackets. I don't know, 20 seconds to multiply those out and feel good about my adding and subtracting. It might even save you time on the test because you don't have to go back and check it later. After you did this, you're like, oh, it's right. I don't have to come back. Yeah? So things like that, those checks, don't have to be as scary as you might think they are. Any questions about sum and difference of cubes? On the website, there is some other videos there. They're videos I've used in previous years, and there's nothing wrong with them. I like them fine. I just like how I've taught it this time better. Okay, so use that video, and I'll put that video up. Maybe I will have time to get it up before you go. But there's another video from Khan Academy up there. Another video that approaches it differently, has a different way of explaining it. A reference sheet, which is built into my lesson as well. So there's lots of resources there if you're having trouble with this. If you're not having trouble with it, if the lesson went perfectly, you're like, I get this completely, then page 182, number 2 to 9. Even if you're a little behind on stuff, you can do tonight's homework and go back to old stuff afterwards.